Hi, in the last session, we understand some key concepts of NRC. Now let's talk about RRC. We will talk about different RRC states in 4G and 5G, and we will understand how the RRC states works in 5G. And we will also see how the transactions happens between different RRC states. So let's start. The connection of a UE to a 5G network is handled through a state machine, and the transactions happens between different RRC states. Compared to 5G, in LTE we only had two RRC states, RRC Idle and RRC Connected. When the UE is actively sending or receiving any data, then it is in the RRC Connected state. And when the UE is not actively transferring data, then it goes to the RRC Idle state to save battery. The transactions between these two states requires defined process, like establishing a new connection and releasing a connection, etc. And that also involves the core network. These processes are called RRC connect when network set up a new RRC connection and RRC release when network releasing the existing RRC connection. However, there was a problem in this approach from 4G because you frequently switch between these two states. Even for a small amount of data transfer, such as a simple notification or a small message, it requires established connection, and that required signaling every time for the RRC connection process. To improve this situation, 5G introduced a new state called RRC Inactive. The RRC Inactive state allows the UE to save power during the sleep mode, but this state do not release the RRC connections completely. So we have a new state and two new transactions in 5G NR. To move from RRC inactive state and RRC connected state, we use RRC resume procedure. And to move from RRC connected state to RRC inactive state, we use RRC suspend procedure. And for all these switchings between RRC inactive state and RRC connected state, we do not need to set up a new connection or releasing an old connection, because these transactions handled by UE and radio access network. So the core network do not involve here. When a connection is established and the UE enters to the RRC connected state, it also sets up the radio configuration and security parameters for the connection. Now when UE moves from RRC connected state to RRC inactive state, then this is the suspend procedure. And during the suspend procedure, UE and radio access network keeps those radio configuration and security parameters. And then when the UE needs to connect to the network again, for example, when there is some uplink data to transfer, then the UE starts the resume procedure. Resume procedure restores the saved radio configuration and the security configuration data and resume the connection very quickly. Hence, we do not need extensive signaling with the core network. Now, because the resume procedure is faster than setting up a new connection, so it also helps to reduce the latency. In most of the cases, when the UE comes out from the power saving mode, it always tries to connect to the same cell site from which it is previously connected. But if the UE resumes in a cell that is served by a different cell site, then the target node will retrieve the UE configuration from the previous cell site based on the UE identifier. So in 5G, the RRC idle state is mainly used as an initial state or as a fallback if a connection fails. The resume procedure significantly reduces the number of RRC messages between UE and radio access network. In LTE, when we go from RRC idle state to RRC connected state, it took 7 messages, as you see in this picture here. So it takes longer time to connect, means it has more delay. But with this new RRC state, when we move from RRC inactive state to RRC connected state, now it just takes 3 messages. And we have RRC connection established very quickly compared to the legacy LTE network. So this reduction in RRC signaling significantly reduces the latency. And as a result, our network becomes more responsive. And this supports more end user services, which demands better response time from the network. It also reduces the power consumption for the devices such as battery power sensors that only sends a small amount of infrequent data, generally less than 100 bytes of data. Okay, so that's it for today. In the next session, we will have some overview on the 5G core network. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.